Algebra 3 Trig, Chapter 6, Section 3, Trigonometric Functions of Any Angle. All right, so defining trigonometric functions using right triangles limits us to using only the acute angles in a right triangle. And remember, we have far more angles than just that. We've expanded our understanding of angles by placing them on the coordinate plane with the vertexes 0, 0 in standard position. And now we can do positive angles, negative angles. It can be greater than 90, they can be greater than 360. We have all kinds of angles, so we need to expand our ideas about the trig functions to match our expanded idea about angles. All right, so let's let theta be an angle in standard position, and xy is going to be a point on the terminal side of theta. So as you see here, we've made a little triangle with that setup. You have your angle. The terminal side we're going to call r, and xy you see there. And what we're going to do is we're going to drop a vertical line from xy to the x-axis, and that's going to form the third side of our triangle. The initial and terminal side of the angle forms the other two sides. Notice the height of our triangle is y, and the base of our triangle is x. So our initial side, the base there is x, the height is y, and the hypotenuse is r. So using the Pythagorean theorem, r squared equals x squared plus y squared. So r is the square root of x squared plus y squared. Now, using x, y, and r, we have that the sine is y over r, the cosine is x over r, and the tangent is y over x. And then you see the reciprocals there. Now, when x is 0, and it could be that we have a 90-degree angle, which in that case, x would be 0. Tangent, secant are undefined. And when y is 0, which would be if we had a 0-degree angle, cotangent and cosecant are going to be undefined because the zeros would be in the denominators. Now let's talk about reference angles for a minute, because doing the triangle thing is really great if your triangle's in the first quadrant, if your angle's in the first quadrant. But what if it's not in the first quadrant? What if you have a 150-degree angle? How do you make a right triangle out of that? Well, what we do is we use what's called a reference angle. For an angle theta in standard position, the reference angle is an acute angle formed by the terminal side of the angle of theta and the x-axis. All the trig values for the reference angles equal the trig values for theta. So we can use the reference angle to find the values for the angle we're actually looking for. So here's some examples of a reference angle. In the first quadrant, the angle and the reference angle are going to be the same thing, because the angle itself is going to be between 0 and 90. So no big deal there. In the second quadrant, notice here we've got a big angle drawn. Maybe it's 150 degrees, maybe it's 145 degrees. A is the angle we're given. You see the reference angle there. What we would do is we would figure out the degrees of that reference angle, which you would do 180 minus the given angle. That would give you the reference angle, and that's the angle that we would use. And you see where it would be in the third quadrant. Notice that the reference angle is always between the terminal side and the closest part of the x-axis. It's always an acute angle. So you see A and you see the reference angle. To figure out the measure of the reference angle, you would take A and subtract 180. And then for the fourth quadrant, you see the reference angle there. And for this one, you would say 360 minus the angle they give you, and that would give you the value of the reference angle. Now, if you have a negative angle, probably the easiest thing to do is to find a positive coterminal angle. Remember, a coterminal angle is what you get when you add 360 for degrees or 2 pi for radians to the angle you're given, and you can do that repeatedly till you get a positive angle, and then you can find the reference angle for that. The signs on the trig functions can be determined from the quadrant in which the terminal side lies. So, for example, in the first quadrant, both x and y are positive. since our sine, cosine, tangent, and all that depends on the values of x and y. By the way, r is always going to be positive, because to get r, you have to square x and square y, and that makes them positive. So r will always be positive. So the signs on our trig functions depend on the positive or negative value of x and y. Well, in the first quadrant, x and y are both positive. So all of our trig functions are going to be positive in the first quadrant. In the second quadrant, we have a negative x and a positive y. Well, sine is y over r, and its reciprocal is r over y, cosecant. So those are going to be positive in quadrant 2. Quadrant 3, everything else, though, will be negative, because everything else has an x involved, which is going to be negative. In quadrant 3, we have both sine and, or both x and y negative, which means that the tangent and the cotangent will be the only positive ones there, because tangent is y over x, cotangent is x over y, and a negative divided by a negative is positive. Everything else will be negative. And then in the fourth quadrant, our x's are positive and our y's are negative, which means our cosine and secant will be positive because they rely on the value of x, and everything else involves a y. So you see that spelled out here. And there's an easy way to remember it. You can make a sentence out of it. Here it's all students take calculus. Another sentence that some people like to use, especially those taking trig, is a stupid trig class. It doesn't matter what you use to remember it. If you're going to use the second one, I prefer you say it in your head, not out loud. Thank you very much. But whatever it takes to remember them, you do need to know what quadrant has what functions that are positive. So find a way to get it into your head. Make a point of knowing that. All right, so to evaluate the trig function of any angle, first of all, determine the value of the trig function at the reference angle. Determine what sign is going to go on that trig. It's pretty much that simple. The domain of sine and cosine is all real numbers. In other words, you can take the sine or cosine of any number in the world. The range, though, is -1 to +1. That's as far as it goes. Nothing below -1, nothing above +1. Think about the unit circle. Okay, the unit circle is a circle of radius 1. X and y stay between -1 and 1. Since sine of theta equals y and cosine of theta equals x, when the radius is 1, the sine and the cosine must stay between -1 and 1. And remember that we said you can actually go multiple times around the circle. Each addition of 2 pi or 360 to an angle brings the terminal side all the way back down to the original side or to the initial side. So every 2 pi radians, our trig values repeat. It's a cycle because it just brings them back around. This type of pattern is called periodic. A function is periodic when there exists a positive real number c such that f of t plus c equals f of t. In other words, when you add the same number, a certain number, to the function, it just brings you back to the starting point. And that's what happens with our trig functions. And that has to happen for the entire domain. The smallest number that makes that happen is called the period of the function. So all of our trig functions are periodic. Sine, cosine, and their reciprocals have a period of 2 pi. Tangent and cotangent have a period of pi, and we'll talk about that later. Cosine and secant are even functions. All the rest are odd. Right. So what you're going to do is determine the exact value of the 6 trig functions for the angles that are given. Real easy way to do this. Finish up the triangle. Make a triangle out of this, and then you're good to go. Just use your ratios. Pause the recording, give it a try, and resume to check your answer. Okay, make sure you found the radius correctly, found r correctly. And after that, it should have been pretty easy. Okay, for this example, they're giving you a point on the terminal side, determine the value. So this is the same thing we did a minute ago, except this time they didn't give you the picture. You draw the picture. Pause the recording, give it a try, and resume to check your answer. Now you actually don't have to draw the picture. I prefer to do that, but you can use the ratios. The sine is y over r, cosine x over r, tangent y over x, and so forth. Okay, for this example, we need to state the quadrant in which the angle lies. Now, this is not two separate problems. These are both parts of the same problem. What quadrant would an angle lie in if the sine is positive and the cosine is positive? Pause the recording, give it a try, and resume to check your answer. All right, the sine is positive in 1 and 2. The cosine is positive in 1 and 4. For both of these conditions to be met, the angle must be in quadrant 1. The next one, find the value of the 6 trig functions if you know that the tangent is negative 15 over 8 and the sine is greater than 0. My suggestion is that you sketch a triangle in the quadrant that has a negative tangent and a positive sine. Pause the recording, give this a try, and resume to check your answer. Okay, so this angle is going to be in quadrant 2, and we have the y is 15, the x is 8. In this case, the y is actually going to be the positive number, the 8 will be the negative. Find r, and then just write your trig functions. Notice that everything is negative except sine and cosecant. Values of the 6 trig functions with these given constraints. Pause the recording, give it a try, and resume to check your answer. Okay, the cotangent is x over y. It is negative 3, so it's negative 3 over 1. It is in the fourth quadrant because the cosine is positive. In the fourth quadrant, our x's are positive and our y's are negative. Again, another approach to this is to actually draw the triangle in the fourth quadrant. I kind of like that because I tend to be more visual, but it's up to you how you want to do this. You need to figure out r, and once you do that, just put the numbers where they belong. For this one, cotangent is undefined, which may be a little puzzling. It's between pi over 2 and 3 pi over 2, so we know that it's in the third quadrant. If it's undefined, that means it has a 0 denominator. Cotangent is x over y, so y must be 0. So where that needs to be is, I think I said this was in the second or third quadrant. This is actually second or third quadrant. So it goes anywhere from pi over 2 to 3 pi over 2. So it's second or third quadrant. Y must be 0. Well, that happens when the terminal side is flat on the x-axis, which would make it have a value of pi. Once we know that it's pi, and we know that the point, if you want a point that corresponds to that, the point would be negative 1, 0, and then you can put them into the ratios there. All right, the terminal side of an angle lies on the given line in the given quadrant. Find the value of the functions. All right, this sounds a little difficult, but it's actually not. What you're going to do is you're going to draw yourself a little graph. At least that's what I like to do. I'm going to graph on that the line y equals negative x. This is telling me that it's somewhere in quadrant 2. So I'm going to completely ignore the part of this line that goes through any quadrant but 2. All you have to do is pick a point on that line in that quadrant and use that as your reference point. Preferably pick one with numbers that are easy to work with. Pause the recording, give it a try, and resume to check your answer. Okay, easiest point to work with on this line is going to be negative 1, 1. So use that to find r, and use that to find your ratios. Evaluate the trig functions of the quadrant angle if you can. Quadrant angles are angles that lie on the axis. And remember, for 0, you're going to have the xy point 1, 0. For 90 or pi over 2, it's going to be the point 0, 1. For pi or 180 degrees, it's going to be negative 1, 0. For 3 pi over 2 or 270 degrees, it's going to be 0, negative 1. Pause the recording, try these out, and resume to check your answer. With the quadrant angles, which quadrant angles or quadrantal angles are angles where the terminal side is on an axis, you really you can't make the right triangles to do these. You have to know the points at the on the 4 parts of the axes. Okay, find the reference angle, which is called theta prime. Sketch theta and theta prime in standard position. Pause the recording, give this a try, and resume to check your answer. Okay, for 160 degrees, we are going to have a reference angle of 20 degrees. And for 2 pi over 3, we're going to have a reference angle of pi over 3. Now evaluate sine, cosine, tangent without using a calculator. What this means is you're going to need to find a reference angle. That reference angle is going to correspond to either 30, 60, 45. Or it could possibly be one of the quadrantal angles, 0, 90, 180, or 270, or 360. So it's going to be a special angle that you should know or be able to come up with the trig function for without using your calculator. Pause the recording, give it a try, and resume to check your answer. Sorry about that. I think I let that go a little quick. But anyway, the reference angle for 225 is 45 degrees. It is in quadrant 3. That is important because you need to know what signs to place on everything, and you see there the final answers. And then for 750, we have a reference angle of 30. It is in quadrant 1, and you see the sine, cosine, and tangent. Thing for the angles in radian measure. Pause the recording, give it a try, resume to check your answer. Okay, for 2 pi over 3, our reference angle is pi over 3. It is in quadrant 2, and pi over 3 is 60 degrees, so use that special triangle. And you have sine, cosine, and tangent. Don't forget the appropriate signs. For 5 pi over 4, our reference angle is pi over 4, which corresponds to a 45 degree angle. So using that reference triangle, you see here the solutions that we have. Again, this is going to be in quadrant 3, so make sure you put the appropriate sign on your answer. Okay, a little bit more of the same. Pause the recording, give it a try, and resume to check your answer. For the first one, you can't, like I said, you can find a reference angle for it. You can, but the easiest thing to do when it's in the 4th quadrant like that, because negative pi over 6 is just pi over 6, but it's instead of going up into this 1st quadrant, it's down into the 4th. It's going to have all the same values as pi over 6. So just find the values for those. It's a 30 degree angle. And since it's in quadrant 4, your cosine will be positive. For 9 pi over 4, our reference angle will be pi over 4. And you see here what we have. And an easy way to remember it with the radians is if you have an angle in radians and it's fully reduced, okay? If it has a 6 denominator, it's going to have a pi over 6 reference angle. It's going to have a 30 degree reference angle in degrees. If it has a 3 in the denominator, it'll have a 60 degree reference angle or a pi over 3 reference angle. If it has a 4 in the denominator, it's going to correspond with your 45 degree angle on your special triangle, or pi over 4 will be its reference angle. So that's just kind of a general you can use, and then you go and see what quadrant the angle actually lies in so that you know what sign to put on your answers. Indicated value in the specified quadrant. For these, I would make triangles, and I would actually put them in the quadrant specified. Pause the recording, give this a try, and resume to check your answers. Okay, again, here they're using the Pythagorean identity, which is perfectly fine. You can use the Pythagorean identity. You can also, like I said, draw a triangle in quadrant 4, label it appropriately, find the missing side, and then find what you're after. Either way, you should get 4/5. Same thing here. Actually, this one's easier. You got the cosine of 5/8. The secant is just the reciprocal, which would be 8/5. Oh, now you get to use a calculator to evaluate the trig functions, round your answer to 4 decimals, and watch your mode. Okay, check your answers. Make sure you got them correct. These are straight up calculators, so if you missed something, first of all, for secant and cotangent, make sure you put them incorrectly, as is indicated here. For the ones on the left, you should be in degree mode. For the ones on the right, you should be in radian mode. The pi is a dead giveaway that you need radian mode. The tangent of 4.5, radians, generally they don't put a notation with it, but degrees will always have the degree symbol. So if you don't see a degree symbol, it's going to be radians. Okay, find 2 solutions to each equation. Give your answer in both degrees and radians. Do not use a calculator. Remember, whenever they say that, this is going to be one of your special angles. Pause the recording, give these a try, and resume to check your answer. Sine of 1/2, the reference angle for that is 30 degrees, or pi/6. Since it's positive, it must be in quadrant 1 and 2. So 30 degrees and pi/6 is one answer. In quadrant 2, that would be a 150 degree angle, or 5 pi/6. For sine of negative 1/2, it's going to be the same reference angle, but this time in quadrants 3 or 4. In degrees, in quadrant 3, it would be 210, in quadrant 4, 330, and our values in radians would be 7 pi/6 and 11 pi/6. Now do the same thing with these 2 equations. Pause the recording, give it a try, and resume to check your answer. Okay, the tangent equals 1 means we have a 45 degree angle, or pi/4. And it must be in quadrant 1 or 3 since it's positive. In quadrant 3, a 45 degree angle would be 225 degrees, in radians 5 pi/4. For the cotangent to be negative square root of 3, we must have a reference angle of 30 degrees, which would match with pi/6, and it must be in quadrant 2 or 4 to be negative. So the values there will be 150 and 330 in degrees, 5 pi/6 and 11 pi/6 in radians. Okay, so we're going to find the point on the unit circle that corresponds to this number, use the results to evaluate sine, cosine, and tangent. In other words, if you've got an angle of pi/4, and it might help sketch it out. Sketch it in a circle. Sketch it in the unit circle on the graph. And what would the xy value be of the terminal side of that? Pause the recording, give it a try, resume to check your answer. So for pi/4, if you draw your triangle, think of r being 1. Actually, r wouldn't be 1. The side lengths would be 1. So you'd have 1, 1, square root of 2. Then that point is going to be square root of 2 over 2, square root of 2 over 2. And then you see the values there. Basically, it's just the sine, cosine, tangent of pi/4. And for 4 pi/3, it's the same idea. 4 pi/3, though, is going to correspond to a 60 degree reference angle. It's also going to be in the quadrant, in the third quadrant. So you'll notice the sine, cosine, and tangent are going to be the same for a 60 degree angle, but sine and cosine will be negative.